All right, ladies and gentlemen, the objective for this video is to incorporate parallelograms into a two-column proof. It says the following two quadrilaterals are parallelograms. So at this moment, let's think about what we know. We know that the opposite sides are parallel to one another. We know that the opposite sides are congruent to one another. We know opposite angles are congruent to one another. And we know that the consecutive angles are supplementary, and we know that the diagonals bisect each other. I go through that list because it's super important to know that all of the possibilities you have here. This is very, very far from a one-size-fits-all proof. But let's kind of just dive in first and foremost to what we know. Of course, we know that they're parallelograms. Well, because I see one of my number one look-fors, which is vertical angles, I'm going to think about using that to my advantage. So I'm going to say that I know that these two angles, of course, are congruent because vertical angles are always congruent to each other. And if my goal is to show that B and F are congruent to each other as well, what is the best possibility to incorporate all these four angles that I've just marked up? Well, we know that parallelograms have opposite angles being congruent. So that really means that B and this angle CDA, these guys are also going to be congruent to one another. And then these two angles, angle EDG and EFG, are also congruent to one another. So what do we know? Well, I know that angle CDA and angle B are congruent, as are EDG and F by, you could either say the parallelograms opposite angles theorem, or you can write it out and say that parallelograms have opposite angles that are congruent. Okay, so now what do we know? Well, we already did state our vertical angles. We know that angle CDA and EDG are congruent to each other because they are vertical angles. But now do we notice the connection? CDA is congruent to B. EDG is congruent to F. But we've already stated that CDA is already congruent to EDG as well. Hopefully we see that connection, right? We end up having, hey, if A equals B and B equals C, then A equals C as well. Ladies and gentlemen, that's a prime example of our transitive property. And so we can make those connections about parallelograms utilizing our two-column proofs.